Okay, today we are going to practice with vertex form, and the next lesson I'm going to practice with factored form. But for right now, I'm just going to focus on vertex form. So we're going to be doing a little bit of what I've already been talking about the last few days with the left, right, up, down transformations. And so I'm going to show you today what vertex form looks like. All right, so vertex form, it's going to look kind of scary. We have y equals a, parentheses, x minus h, quantity squared, plus k. But the way I'm going to do this, I think, is going to be easier than how I could approach it. So since you can't see me and you can't ask me all the questions you might want, I want to try to keep this as easy as possible. Okay? So the A is how wide the graph is or how skinny the graph is. So I'm going to show you how to do the A. And then inside is the left-right motion, and outside is the up-down motion. So the inside left-right motion and the outside up-down motion, that's what we've already been talking about. Okay? So let's just see what we can do with this. All right, so normally the parent function has its vertex right here at 0, 0. So I want to know, how did the vertex get here? So it went right 1, 2, 3. So the vertex went right 3. And it also, besides going right 3, went down 1, 2. So it went down 2. So I want to try to write the equation in vertex form showing that it went right 3 and down 2. Okay, so remember, left or right is always in parentheses. So to make something go right, do you remember what symbol we use? We use a minus. So to make it go right 3, I'm going to have x minus 3. And then to make it go up or down, that goes in the back. And to make it go down, I need a minus. Okay, so that wasn't as hard as maybe you thought. So it's kind of what we've been doing. It's just we have a picture to look at this time instead of somebody specifically saying from the beginning, go right 3 down 2. Okay, now A is a little new, so I want to show you how that works. So I go to the vertex, and after I go right 1, I want to know what the graph does, and it goes up 2. So after it goes right 1, it goes up 2, so that means your A is a 2. If it would have gone right 1, up 1, your A would have been a 1. If it went right 1, up 3, your A would be a 3. If it went right 1, down 1, your A would be a negative 1. So I'm going to keep explaining A as we go, so hopefully it gets a little bit easier. So after you go right 1, see what it has to do before it hits the graph. And it had to go up 2 before we hit the graph. So that's why our A is a 2. Okay, let's try vertex form for this one. So first I need to know, how did the vertex get here from 0, 0? Because normally it's at 0, 0 for the parent. So to get here, it went left 1 and up 3. So left 1 and up 3. Okay, so to write my equation in vertex form, it's going to be y equals, in parentheses, how will I make it go left 1? What do you think? X plus 1. And then to make it go up 3, I need a plus 3 in the back. Now let's talk about A. After you go right 1, how many does it take before you hit the graph of going up? Going up 1. So right 1, up 1, I hit the graph, so my A is a 1. And that's vertex form. Okay, let's look at this one. So first I want to know, how did the vertex get here when normally it's at 0, 0? So to get the vertex here, we have to go right 2 and up 4. So right 2 and up 4. Okay, so anytime a graph goes left or right, then that information goes in the parentheses. Don't forget about the squared on the outside. So to make it go right 2, what do you think you'd put inside? X minus 2. And to make it go up 4, what will you put in the back? Plus 4. Okay, now because this graph is opening down, I know there's going to be a negative. So first let's see, after you go right 1, you have to do what to hit the graph? You have to go down 1. So since you went down 1, your A is a negative 1. If you would have gone right 1 down 2, then your A would be a negative 2. If you went right 1 down 3, your A would be a negative 3. So to figure out this A, go right 1, and then what does it do to hit the graph? Down 1, it's a negative 1. After you go right 1, if it's up 2, it's a positive 2. After you go right 1, if it's up 1, it's a positive 1. Okay, let's look at this one. So first let's figure out, how did the vertex get here? So from 0, 0, it went left 2 and down 1, 2, 3. So it went left 2 and down 3. Okay, so to write my equation in vertex form, I am going to have parentheses again because there was a left-right motion. Don't forget your little squared. What do you think you're going to have inside to make it go left 2? X plus 2. And to make it go down 3, minus 3. Now, once again, the graph's opening down, so I know it's going to be a negative. So let's see. After we go right 1, it takes going down how many before you hit the graph? It takes going down 2. So this time, our A is a negative 2. And this is called vertex form. Okay, so now I'm going to look at another page, and I'm going to do this again on the other page, but we're going to also throw in a little bit of review to see if you remember some other stuff. So first, let's do vertex form for this picture. So I'm going to write vertex form. Okay, so vertex form always tells you what happened to the vertex. So these problems that I just did, this equation is telling you that the vertex goes right 2 and up 4. So that's what vertex form does. It tells you how the vertex moves from 0, 0. So anytime you put something in vertex form, there's going to be the parentheses because that is the left-right motion, and the number in the back is the up, down. Okay, so how did the vertex get right here when it was supposed to be here at 0, 0 for the parent? So how did it get here? It went left 1, 2 and up 1, 2, 3, 4. Okay, so it went left 2 and it went up 4. Okay, so since there's a left-right motion, I know that I'm going to need parentheses again with the squared on the outside. So to make it go left 2, what do you think? X plus 2. And then to make it go up 4, in the back I'll have a plus 4. Now let's figure out our A. Do you think it's positive or negative? It's going to be negative because the graph is opening down. So after we go right 1, what does it take us doing to hit the graph? We have to go down 1 before we hit the graph. So that means our A is a negative 1. And that's vertex form, and we're done. Okay, so now I want to practice some stuff that you've already learned. We just haven't talked about it in a few days. So let's see if you guys can remember. So first I want to know what the vertex of this graph is. And remember, the vertex is the highest point of the graph or the lowest point. So as an ordered pair, what point is this? Left 2, up 4. It's negative 2, comma 4. Okay, is it a max or a min? It's a max because that's how high it is. Or that's the highest point. And then what's the max value? How high is it? It's 4 high. Remember, the max or min value is always the y-coordinate to your vertex. Okay, the axis of symmetry, if you forgot, this is the vertical line that splits your parabola in half. Remember, all vertical lines are vuxes, so it's going to be x equals, and what's your x value everywhere here? Negative 2. Remember, the vertex x value and the axis of symmetry are always the same. Okay, zeros. This is where the graph touches the x-axis. They're called zeros, they're called roots, they're called x-intercepts, and they're called solutions. So we've got a 0 here at negative 4, and we have a 0 at 0. Okay, the y-intercept is wherever the graph touches the y-axis, and the graph touches the y-axis right there, which is our y-intercept, and that is the ordered pair 0, 0. So this is not only a y-intercept, but it's also a zero of the graph. So sometimes the y-intercept can be more than one thing. Okay, domain. What do you think it is? Do you remember? All real numbers. This graph goes forever to the left and forever to the right. Okay, range. Do you think you remember? The y starts up here at the highest spot with a y value of 4. So the y starts off equaling a 4, and then the graph goes down, 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 down. And when a graph goes down, y's get less. And that's my range. Okay, so the main goal today was to teach you something new, which was called vertex form. And then I wanted to do a little review of some older stuff just to make sure you haven't forgotten. Okay, so now what I want you to do for me is I want you to do number 2. So like I've told you numerous times, if you need to print these pages off for yourself, you can. They're linked on the Canvas calendar. And if you just want to do this on a separate piece of paper, then just do it on a separate piece of paper. But I do want you to find vertex form. It's not asked, so let's write it down. So I want you to figure out vertex form, write its equation, like I've been showing you today. And then I also want you to complete all the rest of this stuff too. So just number 2 here, okay? So number 2, I want you to complete this. Then I want you to take a picture of it, and I want you to post it to Canvas. So take a pic and post to Canvas. That's all for today. Smiley face.